In this lecture, we're going to be talking about elasticity. This is a term that we use to talk about how sensitive quantity changes in relation to some other variables. So if we're talking about price elasticity of demand, we're saying when the price changes, how much does that quantity change in response? And instead of doing like where we're calculating the slope, where a $1 change might always lead to a $10 change in quantity, we're going to be doing a percentage change so that this $1 change is relative to the starting price and that 10 change in quantity is relative to that starting quantity. So we're going to talk about elasticity of demand, elasticity of supply, perfectly inelastic, perfectly elastic, cross-price elasticity, and income elasticity. So we're going to talk about different ways that we can measure sensitivity and what this means, how we use it in economics. So elasticity is really talking about how sensitive are price changes. How sensitive is that quantity change to price? So we're saying if the price changes by 10 cents, 10%, $1, how much is that quantity going to change percentage-wise? And we're going to use an equation where we've got percentage change quantity divided by percentage change price. And we're actually going to look at several different ways of calculating elasticity, but they're all going to follow this same format. Quantity is always going to be on the top. So we're always going to have percentage change quantity on the top, and then price or income, price of related goods, whatever that other variable is, will always be on the bottom. This is figure 5.1 from your textbook. And as you can see, we're going from point A to point B. We are doing a small change. So in this case, it's looking at rides per day, and the price is going to go from 80 cents to 70 cents. So a small change. And the quantity of rides per day in thousands is going to go from 40,000 to 60,000. Okay, so we're just looking at small changes. Now, here we're using algebra to calculate elasticity. If you take some more intermediate courses later on in the future, you'll actually calculate elasticity at a particular point. You can use calculus to do that. Algebra works just fine as long as you're doing small changes. So I'll show you in a little bit that if you go too far, like your points are too big, like let's say we go down all the way down here and we say this is point C. If we were trying to measure elasticity from point A to point C, we're going to get some weird values. It's probably not going to be too helpful because algebra is not good for calculating large changes. It's just good for looking at these marginal changes in price and quantity. So when we're talking about elasticity, we're going to get some values between 0 and 1 or greater than 1. We will have some negatives as well, but we're going to ignore that for at least the first part while we're just calculating if something is sensitive or not sensitive to price change. The negative actually doesn't matter. If we see that something is elastic, this means it's sensitive to price changes. You're going to get a number that's greater than 1. And what this means is that that percentage change in quantity is bigger than the percentage change in price, or whatever that bottom number is. So, if we have a 10% change in price and a 20% change in quantity, we're going to have elasticity of 2, right? It's going to tell us that our quantity changed twice as much as price. If we say something is inelastic, that means it's not so sensitive. That quantity change, the percent quantity change, is going to be smaller than the percentage change in price, or whatever is on the bottom. So a 10% change in price might only cause 5% change in quantity. And in that case, we're going to get an elasticity of value between 0 and 1. So between 0 and 1, it means that percentage change on the bottom is greater than the percentage change on the top. If it's elastic, that means the percentage change on top was bigger. And then if they're equal, so 10% price change and 10% quantity change, we're going to say that that is unit elastic or unitary elastic. That means 10% increase in price is a 10% increase, or 10% change in quantity and 10% change in price. They're going to be the same. Depending on if we're looking at supply or demand, if you're talking about elasticity of demand, we're always going to get a negative number. If we talk about elasticity of supply, we're always going to get a positive number. When we're looking at some of the other elasticities that we'll get to near the end, the positive and negative tell us something about the type of good, but doesn't tell us anything about if how sensitive or not sensitive it is. If we're looking on a graph, there's going to be some kind of midpoint on your line where we have unit elastic. In this case, this is demand, so unit elastic demand. And then anything that's getting closer to the y-axis, so over here where we have higher prices and lower quantities relative to that unit elastic point, we're going to see that our demand becomes more sensitive or more elastic. Okay, so the top half of the graph is going to be elastic, and then as we move closer to that x-axis down here, where we have lower prices and higher quantities, our demand gets to be inelastic or less sensitive. This is going to really matter if you're a business. Depending on where your customers are on this line, raising revenue or lowering revenue or prices, raising prices or lowering prices can actually lead to higher or lower revenue. And if you have sensitive customers, so you're over here in the elastic side, you're actually potentially going to increase profit, but definitely increase revenues by lowering prices. And if you have inelastic customers, you're down on this bottom chunk of our graph, you can increase revenue and likely increase profits by raising prices. And so it really matters how sensitive your consumers are to changes in prices. You can hurt your business or help your business doing both things. So you may look at some companies and you say, like, how come their prices keep going up and up and up and they're making money? They probably have inelastic demand, at least their segment of the market. Or other places, they just keep lowering prices. They have really cheap products all the time. How are they staying in business? They probably have elastic customers, where lower prices actually lead to higher revenue and higher profits. All right, so let's look at an example where we actually calculate elasticity. We are going to use this table here. I'm going to assume this gives us our price and our quantity demanded. And this will be like a straight line. So if this was on a graph, it would just be like this. It would have a constant slope. Because for every $1 change in price, we get a quantity change of 10. And that's the same everywhere on this graph, okay, or on this table. So I have a constant slope. This is a straight line. But elasticity is looking at that slope in relation to the starting point. So it's not just that it was a $1 change. It's maybe $1 compared to the starting price of $5, or $1 compared to a starting price of $10. And those are going to give you much different percentages. Same thing with quantity. So 10 compared to 90 is much different than 10 compared to 30. And so that percentage change is going to be really important for us in figuring out how sensitive our customers are. So we're going to use this equation, percentage change quantity divided by percentage change price. Some of the books, some of the resources we're going to use have these two lines on the outside of our equation, and those represent absolute value. And what that's saying is that we don't care about the negative. Okay, so when we're trying to figure out how responsive or sensitive customers are, we do not care if it's negative or positive. We will care about that a little bit later when we're trying to figure out, is this an inferior good? Is it a complement or substitute? It will tell us more about what type of good it is. I'll show you why later. But just for figuring out sensitivity, we just don't care. And so you'll see like about half the resources just say absolute value. The other half, they leave the negative in, but we are essentially ignoring it because it doesn't really mean anything. So we're going to calculate first the elasticity of demand, going from a quantity of 30 to 40. So 40 is going to be our new value. 30 is going to be the old value. Price 10 is going to be the new value, and 11 is going to be the old value. There's actually a couple different ways that you can calculate percentage change. So there's midpoint formula and endpoint formula. Personally, I'm fine if whichever one you prefer to do, especially if it's like a written example. For multiple choice questions though, and other things, I'm going to use the endpoint formula because I think it shows up more often and it matches more closely like how we do percentage changes in like real life on a daily basis. So endpoint formula says you take the new value minus the old value divided by the old value. We're going to take our endpoint minus our starting point divided by our starting point. So end minus start divided by start. We are going to get a decimal. And when we're looking at percentages, if you see a number that says 1, this is going to mean 100%. And a decimal of 0.1 is going to be equal to 10%. And 0.01 is going to give you a percentage of 1%. So if you want to turn it into a percentage from a decimal, then just multiply it by 100. We don't necessarily need to do that right now because we care more about the relationship between the two. So let me just show you how to do that. Okay, so percentage change quantity is going to be on the top. So we're going to say 40 minus 30 divided by 30. Or 10 divided by 30 is going to give us 1/3. This is also equivalent to like 0.33. Okay. On the bottom, we want to do percentage change in price. So our new value is going to be 10 minus our old value of 11 divided by our old value of 11. So you're going to get -1 divided by 11, which is about 0.0909. And then we're going to divide those two. Okay, so 0.333 divided by 0.0909. And that's going to give us a value of, well, the bottom one's negative. So -3.67. And if we take the absolute value, we're ignoring that negative, it gives us a value of 3.67. So what this tells us is that the top value of 0.33 is 3.67 times bigger than that bottom value of 0.0909. Or if we'd gotten a value of 3, right, that would tell us if the bottom was 10 or 0.1, the top would be 0.3. Or bottom is 10, top is 30. Okay, with 3.67, if we have a 10% change in price, that's going to lead to a 36.7% change in the quantity. So it just tells us how much bigger the price or the quantity changes compared to the price. Now this number 3.67, this is greater than 1, so we would say that this is elastic. This is sensitive to price changes. Our quantity changed a lot more than our price changed. Now we're going to do the same thing at another point on this table where we're also still going to have a $1 price change and a $10 quantity change. So we're going to calculate what happens when we go from 80 to 90. So 80 is going to be our old value, 90 is going to be our new value, $6 is going to be our old value, and $5 will be our new value. So when we do that, we're going to do 90 minus 80 divided by 80, which gives us 1/8. And on the bottom, we're going to do 5 minus 6 divided by 6, which is going to give us -1/6. Plug that in, divide, and we're going to get -0.75, or just 0.75 if we take the absolute value. So in this case, we get 0.75. And if you notice over here, 1/8 and 1/6, our bottom number actually changed more than the top. Right? 1/6 is greater than 1/8. So 0.75 tells us that for every change on the bottom, if it changes by 1 on the bottom, it's only going to change by 0.75 on the top. Or if it changes by 4 on the bottom, it's only going to change by 3 on the top. So we would say that this is inelastic. Our customers are not super sensitive to price changes here. And even though prices went down, that quantity did not change percentage-wise nearly as much. Here's another example from your book in figure 5.2. I'm not going to go over all these calculations here in the video. Please let me know if you have questions. But this is looking at 3 different points on the same line. The first one gives us an elasticity of -3. The middle one gives us an elasticity of -1. And that bottom one gives us an elasticity of -0.33. So you can see how on the same line we have an elastic point, we have a unit elastic point, and we have an inelastic point. And it's all because it's relative to where it is, where the starting point, the quantity and the price starting points. Perfect inelasticity or elasticity, or perfectly inelastic, perfectly elastic. This is going to be where we have a vertical or horizontal line. Over here on the left, we have a vertical line. We would say that this is perfectly inelastic. This means that we have a fixed quantity. In this case, it's going to be 5. So the quantity is fixed. It doesn't matter how much up or down the price goes. People in this market are always going to need 5. So some examples might be you need life-saving medication. You have to take a certain quantity every day or every month. And just because the price changes doesn't mean you can have more or less of it. So perfectly inelastic, we have a fixed quantity, and it has nothing to do with the price. Over on this other graph on the right, this is where it would be perfectly elastic. In this case, we have a fixed price, and then the quantity can increase or decrease. We're actually going to see this when we go into our chapter about perfect competition. And while we're still going to have a normal demand curve for the market, the demand curve for each individual firm is going to be horizontal. Partly because in perfectly competitive markets, they can't lower prices because they'll go out of business. They're already producing at the highest or at the lowest possible cost. And they can't increase prices because their competitors will just steal all the customers by still just charging 5. So we're going to see some examples where we do have this horizontal demand curve, and it comes with the idea that prices are fixed and that quantity can increase or decrease. Determinants of price elasticity of demand are categories that help us to explain or understand why something might be more or less sensitive to changes in prices. So, for example, if we're talking about elastic demand, if a product has a lot of close substitutes, a lot of alternatives, customers are going to be more sensitive to price changes. So if I need fruit, I'm going to go to the store. Whatever is $1.99 a pound, I'm going to purchase. If it's apples, great. If it's peaches, I'll get that. If I really want watermelon, but it is $13 a pound, I'm not going to buy watermelon. I'm going to go buy something cheaper. If it takes up a large portion of consumers' budgets, then they're also going to be sensitive to price changes. Even if it just goes up 1 or 2% or 10%, like it's going to be a huge chunk of money for our households. And so they are going to respond proportionally much greater than that change in price. Or if there's a long time horizon, you don't need it right away. So things like furniture. If I want to buy a new couch, I usually can wait until there's going to be a sale. And furniture goes on sale usually 2 or 3 times a year. So if I want a new couch, I can wait a few months, 6 months. I can wait till next year if I need to. I can sit on the floor on the cushions. There's lots of ways to still use damaged couches. So if our customers can wait, they don't need it right away, they're going to be more sensitive to changes in prices. And then on the inelastic side, this is where we're less sensitive to changes in prices. We're still going to buy it even if prices go up. For substitutes, there's either very few substitutes or there's none. If you want that thing, you have to get that thing. So if the price goes up, you're stuck paying it. If it's a small portion of consumers' budgets, then they're going to be inelastic. They're not going to notice. Things like what's It's a good example. Salt. Okay, so any of you recently purchased salt at the grocery store lately? Okay, 1 pound container of salt. Um, Usually you can find this between like $1 and $3, depending where you're going. But if you went to the store, you needed to buy salt maybe for a science project or something else, and it was $4, you're gonna be like, oh well, I'm just not buying that anymore. No, thank you. It was $3 last time. Probably not. You're not even gonna notice. This is not something you frequently buy. If it's a short time horizon, so you need it right away, you can't wait, you're going to be more insensitive to prices. You're going to pay it even if the price is higher, if it goes up. It's still going to follow the normal rules of demand. So higher prices mean lower quantities. But proportionally, most of the people are still going to stay in the market. You're not going to lose the majority of customers. I'm going to pause the video here. I'm going to start a new one for our next section where we're going to talk about changes in revenues, elasticity of supply, income and cross price elasticity. So take a break, take some notes, go do some sit-ups or take a nap, and then come back and watch the next chunk.